All right, hello everybody. And this talk, we're going to be talking about metaprogramming, specifically in Elixir, and how it can be used in a highly trafficked API. And we'll quickly cover the basics of metaprogramming, what it is, how you can use it, when you should use it, when you should not use it. And then I'll go a little bit deeper into how I and people that I've worked with have successfully used it in a web API. But first, just a little bit about myself. My name is Jacqueline Manzi. I am a full stack software engineer and now engineering manager. And I've been doing full stack for over 10 years. And I currently work at a company called Mux. And at Mux, we use Elixir and the Phoenix framework for our API layer. And we really love writing Elixir. We love the underlying Erlang. It's been fantastic. And in particular, metaprogramming has been very useful for building out various aspects of our API. So what is metaprogramming? And before we define that, I think it's probably helpful to first talk about how code is executed when it's executed. So meaning that the code that we write, when does it become meaningful output? So if we take a step back and look at the sort of development process, we all sit down, we write some Elixir code in our favorite editor or IDE. And then since Elixir is a compiled language, not an interpreted language, we compile our code, which will either succeed or fail depending on if we've done things correctly. And this compilation process will take our human readable Elixir and turn it to something called AST, which I'll get into in a bit. But after that, the Erlang compiler is invoked to turn it into Beam bytecode. And if you're unfamiliar with the term Beam, it's just the term that is commonly used for the Erlang virtual machine. Great. So when we're ready for our bytecode to be used, it is then executed on the Beam. Computations happen, programs run, and this all happens at a process we call runtime, right? So the code that we write is normally executed at this process called runtime, but code can also be executed at a step prior to that at compile time. And that's really where this talk is going to focus in terms of metaprogramming, is that code execution at compilation. Okay. So now can we define what metaprogramming is? Yeah, so metaprogramming is a technique that can be used to execute computations during compile time, to generate code, and to enable self-modifying code during runtime. We're not going to get into any of the details of self-modifying code at runtime, but just know that it is something that you can potentially do in Elixir. It's very interesting. It most closely resembles something like reflection in other languages, but we're really just going to focus on that code execution at runtime and how metaprogramming allows us to do that. And that is usually referred to as code that writes code. You've probably heard that before, right? So I mentioned this term AST, right? And so AST is what the Elixir code rewrite is first translated to before it is turned into bytecode. And AST stands for abstract syntax tree. Abstract syntax trees are representations of code as data structures, and they are not specific to Elixir or Erlang. Many other compilers use them for many other languages. But ASTs are used by compilers to verify syntax and semantics and perform optimizations and transformations without having to worry about how the code that was originally formatted by the programmer. So in terms of how AST is formatted in Elixir, first, it begins with a tuple, and then the first element of the tuple may be an atom or another tuple. The second element is a list of metadata. The third element is a list of arguments. Great. So how can we utilize metaprogramming with AST? So let's look again at our code development process, right? We write code, it compiles, and then it is executed at runtime. But if we break down that compilation step a little bit further, we can see some additional steps that happen. First, the AST produces some Elixir code, and we call this version the Elixir AST. And then an expanded set of instructions is executed modifying that AST. And we call these instructions macros. Lastly, the Elixir AST is translated to an Erlang AST, which is then used by the compiler to translate our code into Beam bytecode. And the macros here is what we're going to be using for metaprogramming and is kind of key to how we can utilize it in Elixir. Oh. So how do we write macros? Well, when writing macros, we can utilize three features: def macro, quote, and quote. So def macro is basically how you define your macro. And then quote converts our Elixir code into an internal AST representation. So we can wrap normal Elixir in a quote tag and it will translate it to AST. Now you might be thinking, I just told you that all code is translated to AST at compilation. But what's interesting here is that we can use quote to execute computations at compilation time, which allows us to generate large amounts of code using recursive iterations. And then finally, unquote, it just lets you access things outside of the quote block. So in this example, you're just accessing the A and B parameters outside of quote. Okay, so now that we know how to write macros, when should we write macros? When should we not write macros? And the answer is you should usually probably never write a macro. And that's because you're basically obfuscating code, right, from other people that need to read your code. Anytime code is generated outside of like the code that you can read, it's going to be hard to debug. It's going to be difficult to figure out how things work. So I basically fall into the camp of they should only really be used for reasonable core functionality that requires a lot of repetition and will require typing redundant code. So you can think of that as anything that you could classify as boilerplate code for your application, something that is really common to everything that is utilized in your application, and it's kind of well understood what it does. Right. Okay, so now we're getting to the actual purpose of this talk. What are some areas macros can be practical in a web API? And when you think about a web API, it's made up of various endpoints, and they can all be accessed by an end user, right? And when you think of some of the common functions of each one of these endpoints, there's really three things. It's first authentication, like can you actually access it? Are you allowed? And then there's authorization. Can we allow you in? And then validation. The input that you're giving us, is it valid or not? So we're going to disregard the authentication step here and just look at authorization and validation in terms of macros. Okay, so when we talk about authorization in an API layer, an API layer is basically the gateway to our web application, right? It consists of a variety of different routes that can be accessed by an end user. And when we get past that authentication process, these routes will often have various sets of authorization rules for the user that's attempting to access them. As an example, we'll use a route that allows us to get a list of users, and it has various CRUD functions: get, post, put, delete, right? Let's say you have an application that you want to allow a regular user role to get the list of users, but you'd only want to allow a min user to be able to create a list of users or be able to post to that endpoint. So those are various authorizations that you might want to do on your API endpoints. And then things may get additionally complex when you start to think about things like feature flags, right? So in addition to user roles and access to routes, you may have feature flag plans, right? So if you have an application and you have users that have unpaid plans, so they're like free accounts, you might say, okay, you're allowed to get this list of users, but you can only create a list of users or post this endpoint if you pay us or you give us money. And we might define something along the lines of a feature flag for that. So now you have like these complexities with roles and feature flags, and then you can, I'm sure there's a number of other things you can introduce there, various number of permutations that have to do with authorization. And so when you think about that, in terms of the Phoenix controller, and I'm using the Phoenix controller here because if you're using Elixir, there's a high probability that you're probably also using the Phoenix framework for that API. This is a really common controller example. So basically, if you have an endpoint for a user route and you want to get a list of users, it's going to hit an index function. And so if you want to like gate that to only admin users, you're going to have to put an admin check there, right? And so this, whether or not they're admin user, is going to send them into various states. If it's successful, they'll get a 200 back. If it's not, we'll send them a 401 saying that it's unauthorized. Similarly, you may have to do the same thing if you have a feature flag, right? So this is the unpaid and paid feature flags. So now you have two additional checks. You have the admin user check. Is this a user and admin? Can they update this route? And then, are they also on the paid plan? If so, then we can send them a 200 with the list of users, updated list of users, and otherwise a 401 unauthorized, right? So now, if you consider that, like that's just one example of a controller. If you have a highly trafficked API, you're probably going to have a lot of different routes and a lot of different users that may be providing you various things. They may have probably different roles depending on the complexity of your app. There's also likely going to be a lot of different user input things that they give you, right? So when we talk about like a highly trafficked API, usually it's highly trafficked because of the amount of people that are visiting, right? So there's just probably a lot of business logic and complexity. So if you imagine that you'll have to add all of those checks to each one of your controllers, it's a lot of boilerplate code. So I mentioned earlier, one of the reasons that you would use a macro or metaprogramming, you should never do it really, but one of the reasons you should do it is for sort of consolidating boilerplate code so they're not constantly writing redundant functions. So one of the ways that we can do that, we have an example here with two routes, one for a group list and another for a users list. And they both have delete, create, update, index, CRUD methods, right? One interesting thing we can do is put these routes through a pipeline plug. And in Phoenix, pipeline is actually a really good example of how they utilize macros. So a pipeline is basically a plug in the Phoenix framework that you can use to essentially generate a bunch of code that is boilerplate for your routes. And you can basically send your route requests through all of these various pipeline plug functions. So let's take an example of how we can write a plug and then put it in a pipeline. So we're going to call this one the access restriction plug. And all it really does is we are calling something called authorize on this module called authorizations, and we're passing it our con. And con is going to have all of the request information that came from that endpoint that the user hit, and it's going to have various other information that we've fetched, right? We may have fetched the user model if we're using something like Ecto, and inside of that con, there will also be a bunch of request options that will have basically the route, like CRUD method and query string and all that kind of fun stuff. So we're basically just going to pass that con to this authorize function. And when it comes back, if it is authorized, then like we'll continue the con on throughout the rest of our application. Else, we're going to send that user back a 401 and say that they're unauthorized, right? So let's take a look at how we can actually write macro for this. But first, we can also just show how we can put that in our pipeline. So stepping back to the router again, I talked about the Phoenix pipeline, which is also a macro. We can just create a plug, put in our access restriction plug in there, and each one of the routes will basically get code generated for that pipeline. So it's consolidation there just right out of the box from Phoenix. Cool. So before we write our macro, I also want to kind of touch on how we can define our rules to make this like a little bit easier to understand. So we define a list of route access functions here, and we can utilize another amazing thing of Erlang and Elixir, which is pattern matching. So basically here we can pattern match on what we're passing in our con object. And this is not like a representation of a con that everybody will have. That's just like is an example of what one application may have. So in your con object, you may have a user that you fetched if you've used Ecto, for example. And in this user that you fetch back, you know if the role is a regular user or if it's an admin user, and you can pattern match on that. And then this is, again, specific to maybe your application code and business logic, but you may have feature flags in there, right? And then you can pattern match on a feature flag. So when you fetch those feature flags back from the user that you've gotten back, right, you can say, oh, okay, this person has a paid feature flag. And that means that we're going to let them have access to all of these various routes. And this is how we're going to like define our router access rule definitions. So a regular user in this example has access to a get for the users route and a get for the groups route. And then everybody else who's an admin and has the paid feature flag can do all sorts of other stuff on these routes, right? Okay, so now that you know about this router access rule definition thing, let's talk about how we can actually write a macro for this. So first we'll define our macro, right, using def macro, passing it our con again, and the list of authorized routes that we just defined. And then for each one of those authorized routes, we're going to do some code generation. And the route function generation here is essentially a macro, right? So before we talked about how you can use quote block to start generating AST behind the scenes at compilation. So we're just going to wrap up some functions in this quote. So previously I showed you this other function and it was like a module that said authorizations and it executed authorize, and this is that, right? So basically what you see here is more pattern matching. So we see the con representation of what the AST is going to look like behind the scenes, and you can pattern match on that. So essentially the con object has an assigns key in there. You're going to have the user model, and you may have some feature flags. And then we are going to unquote that method and path info, and this is how we can pattern match on those gets and you know, the slash users, etc. And then we will just do some feature flag checking, and that's how we can utilize if that person is on the paid plan or not, right? So you can see here that's like how you can sort of consolidate a bunch of code for a bunch of different routes, and instead of having to write that logic over and over and over again in every single controller. Is this easy to read? No. Is it going to take people at your company to figure it out? Yes. Is it worth it? Absolutely, I think so. Macros are very powerful, and once you do start writing them, especially for useful things like this, I don't encourage people to write macros for just anything, like you really shouldn't, but for something that is about consolidation and core functionality, it allows you to really understand how Phoenix works, right? Because Phoenix is just using macros all over the place, and other Elixir frameworks are using macros all over the place. So unless you really do start writing macros for something that you're using in your application, you're really not going to really understand how the rest of the code you're writing actually does work. And so I highly encourage it. So we talked about validation, or we talked about authorization. Now, what about validation, right? And so they're pretty similar things. Authorization says, okay, are you allowed to access something, right? And validation is basically like, okay, the stuff that you've given me, is it correct? Is it right? Can we accept it? So when you talk about validation in a API, you're really kind of talking about like specific things. Normally it's about parameter validation. And so some common things that you might check for in an API is around limits. If somebody is giving you a list of things or a string and you don't have a limit on it, then you're kind of open to an attack vector. So you definitely want to check or make sure that you know, you're not running into, you know, you don't cause an on your server because somebody gave you megabytes of information because you allowed them to. So that's one thing that you may want to validate as a parameter. The second thing is something like an expected type, right? So if you are getting a parameter and it has to do with like pagination, for example, one of your routes is like, give me the second page for this. It wouldn't make sense if that pagination parameter is like a Boolean, right? So that's like another expected type thing. And then another common thing is just the expected options, right? So because parameters are usually user-defined input, you may want to do some sanitation on it. you may want to say, you can't just give me anything you want. It might break your application unexpectedly, or it could just open the door to like nefarious actors trying to do things they shouldn't. So those are like 3 common types of validation that you might do in an API. So basically, we can do the same exact thing with validation. We do the same thing we did with authorizations. It's a little bit more convoluted because, again, parameters are something that are kind of defined by your application. It's similar to feature flags, but it's a little bit more convoluted. But essentially, you can utilize the same functionality in this plug. Instead of doing authorization validations, we can do validations. So my app authorizations.validate, same thing. If it fails, we're going to send the user back a 400 and say it's a bad request and not let that request continue on throughout our application. If it passes, we say, great, continue on through the flow of our application. And this is our router access rule definitions again, except this time we put in a parameter there next to the feature flags. So I left it blank because, again, it's something that's specific to the way that you define things. But it should behave the same. And we can do the same type of consolidation with macros. But this time, we're gonna generate the same routes for everything that we've put in there, but also we're going to do this different function called validate, and it utilizes the same exact pattern matching on that con object. And you'll notice here there's a query string parameter because that is something that you also get. So you can verify the query string AST with your what you've defined for that route. You say, okay, this route is allowed to have this type. It's allowed to have this many options of parameters, can't have anything other than these variety of parameters. That kind of stuff would go in here. And that's kind of how you can validate parameters in the same way that we validated authorizations. All right. Okay, so I took a video of this because it was just so much code. But essentially, I wrote an example application, and then I found this open source framework that allowed me to generate the AST based off of that, see it, and then it actually generated it back into Elixir code. So just an example of all of the code that you will be saving yourself from writing, saving your poor wrists by using something like macros and metaprogramming here. And this was just from those 2 routes that I showed you. So it is quite a bit of code, and you can imagine all of the code that's being generated already just with the Phoenix framework itself. So that is the primary reason why I would use macros. Again, there are some functionalities for how you can use it at runtime. So you can, without having to compile code, which is an interesting thing as well. But really, I think that the compilation part of it, being able to execute code at compilation and generate code is really fascinating and pretty useful for an API layer. That is all I had for this talk. Thanks so much. And I hope you learned a lot. If anything, I hope that, you got some ideas.
Yeah, so thank you, Jacqueline. Let's give a warm round of online applause or video applause. Do we have any questions? If anyone has any questions, please unmute and ask. I think we have 1 more minute or less for a question.
Yeah, I have a question.
Yeah,
sure.
Go ahead.
Hey, Jacqueline, thanks so much for the presentation. That was awesome. So if by some chance the team that wrote the macros, none of the members is available and you need to debug this code, how easy is it for someone to debug? Because there are a few lines of code that translate to thousands of lines of code. So how easy do you think it is to debug such a case?
Not easy at all. And I say that because many years ago, I looked at this exact thing and was like, what's going on here? So I would say that you should very much document it if you do. There should be pages about this if you do something like this.
Oh yeah, so your suggested solution is that just properly document your macros.
Yes, and teach everybody you can about macros.